Whoops, this thing works. Okay, good morning. Thank you all for coming at this very early hour on the last day of the conference. I think we're going to have a very interesting discussion this morning. I'm Sean Lovejoy, and I want to thank my co-conveners of this session, Oksana Tarasova and Thomas Blunier, and take the opportunity to introduce our moderator, Julianne Mossinger, who's the senior editor of physical sciences at Nature magazine. She will introduce our debaters in a moment. Just wanted to say that the stimulus for the debate was the sort of different perspectives coming out of Working Group 1, which are the physical scientists, Working Group 3, which is more the social scientists and economists, and of course the policymakers tend to listen more to the Working Group 3 people because they speak more in their language and they talk about economic scenarios. And so, anyway, I won't steal any of the debate, but that was kind of the stimulus for this. So with that, thank you very much, and I'll let Julianne take it over.
Thank you, Sean. Well, good morning. Thank you for joining us. Welcome to the great debate, is 2 degrees possible without relying on carbon storage and capture? So the structure of the debate this morning is going to be as follows. I'll briefly introduce our panelists, then they have about 5 minutes to explain their positions. Then we'll have a brief discussion amongst the panel before opening the discussion to the audience. Then we'll be going back and forth between the panel and the audience, and then finish with some concluding statements from our panelists. And if you would like to ask a question or make a comment later on during the debate, can I please ask you to make your way to one of those microphones in the middle of the room so that everyone can hear your question. So it's now my great pleasure to introduce our very distinguished panel this morning. At the far end, we have Pete Smith. He's a professor of soils and global change at the Institute of Biological and Environmental Sciences at the University of Aberdeen and the science director of the Scottish Climate Change Centre of Expertise. He's a global ecosystem modeler with interest in soils, greenhouse gas emissions, food security, bioenergy, greenhouse gas removal technologies, and climate change impacts on ecosystems. He has contributed to the Intergovernmental Panel on Climate Change Assessment Reports for over 2 decades, most recently as a convening lead author for the Agriculture and Forestry chapter of the Mitigation Volume. And this week he was awarded the EGU Philippe Duchaufour Medal for distinguished contributions to soil sciences. Next to Pete, we have Helene de Koning. She's an associate professor in innovation studies at the Environmental Science Department at Radboud University. Her main field of work is at the interface of international climate policy, energy, and technology. She was one of the editors of the IPCC Special Report on Carbon Dioxide Capture and Storage and has advised international institutions and governments in the field of carbon capture and storage. And currently, she's the coordinating lead author for the IPCC's Special Report on 1.5 degrees in the chapter on strengthening and implementing the global response to the threat of climate change. And she's also a board member of the Climate Policy Research Network, Climate Strategies. And next to Helene, we have Sarah Mander. She's a senior research fellow at the School of Mechanical, Aerospace and Civil Engineering at the University of Manchester and at the Tyndall Centre for Climate Change Research. Her professional experience extends well beyond academia, including work as a project engineer in the chemical and pharmaceutical industry and for an urban design company promoting sustainability within urban neighborhoods. Her current research interests are focused on climate change mitigation, renewable energy, long-term energy scenarios, sustainable energy in the urban environment, recycling, and climate change governance. And here to my left, we have Thomas Gasser. He's a research scholar in the Ecosystem Services and Management Program at the International Institute for Applied System Analysis. He's an Earth system and carbon cycle modeler with core interests in climate change scenarios and drivers and feedbacks in the Earth system, with a particular focus on the land carbon cycle and land use change. His research also explores the attribution of human-induced climate change to specific countries or economic sectors. Pete, would you like to start the debate?
Yeah. Thank you, Julianne. Looking at whether we can do 2 degrees without carbon capture and storage, If we look at the IPCC Working Group 3 scenarios from the 5th Assessment Report, 87% of all the scenarios that are consistent with a 2-degree warming use negative emissions of some sort. By negative emissions, we mean greenhouse gas removal, so removing greenhouse gases from the atmosphere. Most of those scenarios use bioenergy with carbon capture and storage. So carbon capture and storage is central to many of the projected pathways to reach 2 degrees Celsius. And not only this, carbon capture and storage is not only an important technology for BECCS, but if we're thinking about the continued use of fossil fuels, as we phase out fossil fuels, we're probably going to have fossil fuels in the mix in 2030, still a fair proportion in the 2030, and going out to 2050 as we begin to phase fossil fuels out, there's still going to be some fossil fuels in the energy mix. So given the fact that they're going to be there, it seems ridiculous to me that we wouldn't try to use carbon capture and storage to prevent some of that CO2 going into the atmosphere. So whether you believe in large-scale bioenergy with carbon capture and storage, or whether you think that we should be phasing out fossil fuels more rapidly, in my opinion, we need carbon capture and storage to reduce those impacts. And indeed, the excellent paper by McGlade and Eakins in Nature in 2015 shows that without carbon capture and storage, then we are in serious trouble. So there are alternatives to carbon capture and storage. So there are natural pathways for carbon sequestration. For example, restoration of organic soils, restoration of degraded lands, restoration of coastal margins, and also reforestation on land areas where it doesn't compete with food security. So there are alternatives, but we estimate that we could probably get about 10 gigatons of CO2 equivalents per year from this. So it's not enough it's not enough to avoid the fact that we've got carbon capture and storage. So in my opinion, I think it may be possible to meet 2 degrees without CCS, but probably only if we start thinking about other, even more risky technologies such as solar radiation management. So if we don't want to go down the solar radiation management road, and we want to maintain our climate at 2 degrees without using solar radiation management, I think that we do need CCS. And it's really not a matter of need. I think it's a sort of a moral imperative in a way to invest in the technologies, to demonstrate them at scale, so that we can reduce the amount of carbon dioxide that we're going to be putting into the atmosphere over the next 20, 30 years. I can't imagine any other form of pollution where we would say, we know how to do it, but let's not try it. So I really think that we ought to. Thank you.
Thank you, Pete. Helene?
Yeah, thanks very much, and thanks for having me here. So do we need carbon capture and storage to stay below 2 degrees centigrade? I think physically, no. We could do it without CCS. So just as a thought experiment, suppose we would manage to stop all fossil fuel exploration and mining by 1st of January 2018. We just stop it. We just make a rule, a global rule, that we quit. It would have an enormous impact on the economy, on everybody's lives. It would probably be pretty disastrous. We'd be transferring very quickly into a war economy, but we wouldn't need CCS, and we would probably stay below 2 degrees centigrade. So physically it's possible. Also, as Pete said, there are some models that are giving scenarios in which CCS is not needed in order to stay below 2 degrees. You need very rapid behavioral change, probably get very rapid innovation, and maybe it's actually the better scenario. However, if we go to the real world, I'm afraid we need CCS. To me, it's really a necessary evil, and I think there's 2 or 3 reasons, which I think are all very compelling, that require the need of CCS. One is, as Pete said, the need for negative emissions, which are just generally easier with CCS in combination with biomass. It's less intrusive, it has less land use consequences, and therefore probably less social consequences. A second one is CCS in industry. So everybody tends to think about coal-fired power plants, gas-fired power plants, and the electricity sector in the scope of CCS. But imagine how to make cement without CO2 emissions. I mean, it's basically, the CO2 is a result of the processing of limestone into cement. It's very hard to avoid those emissions, and that's about 50% of the emissions of cement production. So if we want to keep on using cement, which is a key ingredient of the building sector, you probably need CCS in order to reduce emissions to 10% or something of what they are now. So that's industry. Also in steel, it's very hard to imagine making steel without CCS. So I think we need it actually much more in industry than in the electricity sector. And the third reason, to me, is more political. If you don't use CCS, it basically means a much quicker phase out of fossil fuels. That means that we'd have very strong losers in the energy system, and that's the fossil fuel industry, particularly the oil and gas industry. Coal is probably going to lose out pretty quickly anyway. And to have the oil and gas industry as your opponent in your political process in order to get to policies that result in a 2 degrees or even 1.5 degrees world, you're really in trouble. It's a very powerful industry. And it is at the basis of many of the products that we're using, of the energy that we're using, the way we are transporting ourselves. It's really a very powerful opponent in the political scheme. And CCS is the only technology that makes this industry part of the solution and not only part of the problem of climate change. If you look at a recent paper published by IPICA, which is a sort of an environmental and social issues association of the oil industry, where all the big oil and gas companies are part of, including Exxon, Chevron, and all the kind of, very bad guys in a way. They give scenarios for 2 degrees, and they all include massive amounts of CCS. So if you want to realistically, politically get out of the climate change issue, I think for that reason we need CCS. The next question is, are we getting CCS? Aren't we taking an enormous risk by relying on this technology so much? And if you say, well, we use solar radiation management as a deterrent to actually get more CCS in. Actually, when I was involved in the IPCC special report on CCS more than 10 years ago, we used CCS as a deterrent to get more energy efficiency and renewable energy. So the debate is definitely shifting, and we're getting into more extreme and more radical technologies as time goes along, and too little is happening in order to reduce emissions. So I'm not sure if that argument will actually work, Pete, but we do need a global and a very thought-through strategy to get CCS implemented responsibly. And I'll leave it at that. Thanks.
Thank you. Sarah?
So, good morning, everyone. I'm delighted to be here in Vienna. And I suppose I'm speaking here as someone who, in addition to the other work I've done, I've been working on CCS now for over 10 years, mainly looking at social responses to the technology. And yes, I would say the arguments for why we need CCS are compelling. I think one of the biggest arguments is that CCS it's an attractive technical fix. It's an end-of-pipe solution that supposedly could be slotted into our existing energy system, our existing ways of doing things. It's a technological solution to climate change mitigation, which in many ways isn't a technological problem. It's a social, it's a political, it's an economic problem. And I think one reason why it's so attractive to policymakers is it allows them to think that by deploying a technology, they can avoid those bigger issues, some of which Helen has just flagged up, kind of taking on your fossil fuel lobby, for example. If you don't have to take on your fossil fuel lobby, you can stick in some amine scrubbers, and then you can inject your CO2 into a geological formation. It's in essence a far more attractive solution, I would say, particularly when we're in the context of having been trying, many countries have had climate mitigation policies for decades, and yet we're still in a position where emissions have continued to rise for a significant portion of time. So I mean, if we look at, I suppose, the history of CCS, Ellen mentioned the IPCC report in 2005, and following that report, there was a huge amount of political attention and interest in carbon capture and storage. And here in the EU, we had a target, I think, for 12 CCS plants by 2015. So we're now 2017, and how many carbon capture and storage plants have we got in Europe? That'll be none. There is one integrated plant in Canada with possibly, hopefully, the Kemper gasification plant opening in the US in 2017. So if we look at this quite optimistically, by 2020, we may have 3 fossil carbon capture and storage plants globally. If we then kind of look at the scale of CCS that's actually required within the AR5 scenarios, and just looking at the amount of carbon which would need to be sequestered from BECCS, from bio-CCS. So this isn't fossil CCS, this is just BECCS. We're probably looking at between 2 and 10 gigatons of CO2 per year. Now, the Kemper gasification plant would sequester 3 million tons of CO2 per year. So already, just looking at BECCS, we would need, by 2050, between 600 and 3,000 bioenergy plants. We would need to then transport and store that CO2. So we're possibly looking at a CO2 transport network which is maybe 10 times as big as our current natural gas transport network. So from an infrastructure perspective, from a ramp-up rate, from the work that has to be done, there's a huge amount that is needed. Now CCS, it's still a very diverse set of technologies, as is bioenergy with carbon capture and storage. So there's a huge amount to be done in integration in technological development. There's also a huge amount that needs to be done in terms of the broader socio-technical systems, so the skills we need, the regulations we need, the governance systems. So in order to achieve global net negative, we would need a global government system for carbon accounting that allowed you to account for the take-up of CO2 between your sources and sinks. We're looking at huge global cooperation where, frankly, I look at the world today and I see countries look like they're less likely to cooperate rather than more likely to cooperate. So in terms of is 2 degrees possible without carbon capture and storage? Yes, as Hélène said, if we go down a completely different route. Is carbon capture and storage possible? You see, that is where, for me, that big question rises. Thank you.
Thank you. Thomas?
Hi, everyone. So being the last one to speak and seeing that we, I think, more or less all agree on the answer to the question, well, I try not to repeat too much what has been said so far. But since I'm a carbon cycle modeler, I'd like to talk a little bit about that and discuss a little bit this carbon capture and storage. I mean, the name. Obviously, we are all agreeing that we are mentioning the technology of capturing, like artificially capturing carbon from a power plant to store it in the ground. But there is some natural carbon capture and storage going on at this very moment. So far, we've been granted a 50% discount on all our CO2 emissions by the natural carbon sinks, free of charge. And the question of how these carbon sinks will evolve in the future, I think, is quite crucial in the question of how we can and if we can reach 2 degrees. So this was just to mention the natural carbon capture and storage. Now to the question, because obviously we are discussing the anthropogenic carbon capture and storage. So my answer to the question is no, I don't think we can reach 2 degrees without that kind of a technology. So why? Maybe, I don't know, some figures have already been given, but if we work with a simple carbon emission budget, I should say, basically, so it's a very simple and not very accurate way to think, but at least it allows to have a basic idea of what we need. And so basically, to reach 2 degrees, we can emit something between 800, 900 gigaton of CO2 in total. And after that, nothing. So we are emitting currently something about 40 gigaton per year, I think. So which makes basically we have, at the current rate of emission, about 20, 25 years left. And again, after that, nothing, zero. Of course, we can think of a more realistic way of putting this emission in the next future, so with a very, very fast decrease of emission. But the thing is that currently the anthropogenic CO2 emissions are growing, although there is some debate with the very recent latest data. I think on average we're still growing at about plus 2% per year rate. And to exactly reach those 2 degrees, so to follow this total budget, we would need to decrease very soon at a rate of about -4, -5% per year. So this is a complete drastic, extreme change. So how can this change happen? Well, basically 2 ways, as always. We can imagine a technological breakthrough, something like, I don't know, tomorrow we figure out nuclear fusion, then no problem. This seems unlikely. So if it's not that, if it's not this kind of a technological breakthrough, we need an extreme change in behavior, that is to say an extreme change of our society. So nothing points toward anything like that. So then we need carbon capture and storage. And so once we've agreed on this, obviously, I think the question is what next? So I think we have a good idea of how much carbon capture and storage we need, and now the key question is how much can we get? So this is a much more difficult question, and I'm not sure we can really answer this one. I'm quite pessimistic as to the answer, but maybe it's a personal view. But there are also other questions then, what technologies can be used and what are the impacts? And actually, so as we said, this how scalable the current prototypes is a key question, and at what rate can we really implement and scale up all those, experiments? I mean, so just to give one other figure, because I think it was interesting about the actual capture capacity that is currently exists. So the figure I have is about 30 million tons of CO2 that is captured every year, which is really, I mean, not much. But there is a very interesting issue there about the fact that only a fraction of that is actually monitored and verified. So there is also the issue of being sure that we are actually capturing what we think we are capturing. Thank you.
Thank you all. So you all said we need carbon storage and capture, but we don't have it. And in particular, Sarah, you laid out that it's quite a daunting task, it seems, to get there. So I was just wondering 2 things. Is it really more difficult to take on the oil industry than developing carbon capture and storage? And sort of what are the major obstacles actually in developing different carbon capture and storage technologies at the moment? Anyone?
Thank you. So is it more difficult to take on the oil and gas industry? It shouldn't be, but I think a lot of it still comes back to the point that that it's for me it's a political challenge. It's not, the political challenge is far greater than the technological challenge. So I come from the UK. In the UK, maybe 10 years ago, the kind of politically, with the government at the time, we wanted to be leaders in CCS, in carbon capture and storage. And there's a very good research base. There's the oil and gas industry. So we had a carbon capture and storage competition in order to be able to fund it, so to fund our first plant, and then that competition was abandoned. And then we had another competition, And again, kind of companies invested and funding was put in, and then that competition was abandoned. And why were those competitions abandoned? I think they were abandoned essentially because there wasn't the political will within the government to push forward carbon capture and storage as a solution. And so the technological integration will be challenging. You know, there's a diversity of technology options at the moment. Going forward, people will end up inevitably investing in the wrong technology and ending up with the less efficient option, for example. But essentially, technologies need to go through that process of innovation of winners and losers in order to kind of to develop. I think for me, the biggest challenge is looking at the socio-technical system, is the regulation, is the governance, and that's where there's the lack of political will.
I would say that it's perhaps not really a fair characterization to say, should we do CCS or take on the oil and gas industry? You know, the oil and gas industry or the fossil fuel industry are actually providing what we're demanding. So it's easy to say they are over here and we're over here and they're doing something bad. You know, I think that we're going to have, we use, you know, we are currently addicted to fossil fuels. It's going to take us a while, and probably going cold turkey is not the way to deal with that addiction. So we need to wean ourselves off fossil fuels. And the way to do that is for other technologies, other low carbon technologies to come online. So I think we're going to need CCS whilst we wean ourselves off fossil fuel, irrespective of whether we take on the oil and gas industry. And CCS gives us that, it gives us the opportunity. So I think, you know, if we need to be, I totally agree with Sarah, we need to be doing the demonstration projects so that we can work out the economies of scale, so that and we learn way more by doing than we do by looking at these things in an integrated assessment model. It's when we get out there and we try different technologies, different capture, different, you know, amines versus sodium hydroxide versus maybe some other ones that we haven't even thought of yet. And also the, you know, the whether, how we store that carbon. Do we store it? Do we try and mineralize it? Do we put it under pressure and pump it down underground? These are engineering solutions which I know little about, but I do know that you get economies of scale, and know that unit costs come down as we work out these technologies. So I think large-scale demonstration projects, whether we think there's a moral jeopardy issue or not, I think we have to do them because we're probably going to need it. So we need to do it. We need to do it well, and we need to learn.
So remember, right after the IPCC special report on CCS 2005, right, there was a lot of political attention. Funds were put into demonstration programs, mainly in the electricity sector. Now that had a bit of a backlash because it was perceived as taking money away from investments in renewable energy and in energy efficiency. So what happened is that CCS kind of became a competitor of the renewable energy lobby, basically. And that's where you don't want to be, right? You want this to work together in order to prevent climate change, because it's all we're all basically in the same boat here. But what happened is because of this focus on electricity, that was the consequence, and that's why I'm really arguing for also the 12 demonstrations that the European Commission was trying to get off the ground. They were all electricity sector based, and none of them happened, and that has other reasons, mainly because the CO2 prices in the emission trading scheme went down significantly, so that took away part of the economics. And the reason for that was mainly the economic crisis, which started in 2008 or so. So there's always a dependence on all kinds of coincidences in the system, and CCS was a big victim of that. But if you would focus on CCS in industry, which does not compete with renewable energy so CCS in the steel industry or in the cement industry, and even in refineries, you could do it there without taking attention away from renewable energy and without competing with that. So and we have the solutions for electricity, right? You just need to put way more money and way more investments into solar energy, wind energy, all the options that you are all very much aware of, and energy storage in order to deal with the intermittency issues. So if you can do that, and then for the other sectors, focus on CCS, demonstrate it there at scale, and try to get more experience there. And there's another advantage there, is because we need a lot of CO2 storage potential underground later on in this century if you want to stay below any kind of temperature target. If we're going to waste all this capacity by putting coal-fired power plant CO2 into those reservoirs, it's going to be gone forever, right? It's going to be used up. It's a finite resource, underground CO2 storage capacity. So you want to save it for the stuff that's really important. And that's, I think, emissions from industry and emissions from biomass plants, so that we can go negative later in the century. But that's, of course, a huge planning issue, which is really, really difficult, as Sarah pointed out. And yeah, we'll have to see how we deal with that. But yeah, focusing only on industry would be a good start, and it's very clear.
I think, Sarah, do you want to come back on Pete, or is that done now? Thomas?
Yes, two comments actually. First, I totally agree with Pete regarding learning by doing. I mean, we really need some investment in the research if we want to do it. I mean, we're really not at the scale we need right now. And so to get that, we really need to invest, to start learning. But so the initial question was more about the political challenge, but I do believe there is a real technical challenge. I mean, the level we are at currently are very, very low. I mean, 100 times lower than they should be. So going from 30 million tons to 100 times that in a few years, that's what's needed, is a real challenge, and I'm actually not sure we can really manage to do that. But maybe it's not that much of a problem, in the sense that everything we can get, everything we can actually capture and store is something that it's a win, I would say. So it's part of the mitigation process. And so it's a good thing, even if we cannot get the total amount, for instance, what's given in the IPCC reports, or what's simulated by these integrated assessment models. But so I think there is a real risk to stake everything on this technology, particular technology, because we are not sure this can really pan out. We're not sure.
Thank you. I think we should open discussion to the floor now. Are there any questions, comments? If there are any questions or comments, can you make your way to the microphones, please? Anyone? No? They're all waiting for you here.
Well, I'll get this started. Anyway, thank you very much for interesting comments. And I guess maybe I will show my hand a little bit in terms of my view. I was influenced by Kevin Anderson's piece in Nature Climate Change, I think it was in October. And he talked in the end about moral hazard of essentially relying on CCS so heavily in order to make economic scenarios, essentially, that would allow us to have 2 degrees. And the fact that there were all these technical issues that were so daunting. So clearly, any CCS we can do is a good thing. Obviously, the question really is, though, is it possible to do it at the scale that has been, in fact, proposed by many of these integrated assessment models? I guess maybe that would be. So anyway, that would be a more precise question to, I don't know who is the one that would want to engage with that, but.
Pete is volunteering.
So I'll take the moral hazard question first, because I think that's very important. So the argument is that if we rely on negative emissions, if we rely on carbon capture and storage, then it weakens our ambition for mitigation. And I used to feel exactly the same way. When we first wrote that paper looking at the externalities associated with negative emissions, which was in Nature Climate Change, it was before the Paris Agreement, and we were framing this around, do we really want to rely on these technologies where we have so little knowledge about the potential negative externalities. After Paris, I changed my position, looking at what needs to be done. When 2 degrees was put on the table, when the aspirational target of 1.5 was put on the table, I changed my position to we need to do it as well as. So CCS and negative emissions are not an alternative to aggressive and immediate mitigation. We need that absolutely totally. That's their bottom line. But I'm now thinking that on top of that, we also need negative emissions or greenhouse gas removal. So it's not an either or anymore. If we want to hit 2, and especially if we want to hit 1.5, I think we need to do both. On the technical upscaling, I think we've had already some excellent suggestions about how difficult that's going to be. But I do know that we won't learn how to do it. We won't get the unit cost down unless we try it. So we do need these demonstration projects. Even if it may turn out some of these may end up to be money that we spend that goes down a blind alley. But maybe 1 in 10 will give us a significant breakthrough, which will allow us to upscale. If we deal with the scale of the problem, as we should, this is the most significant issue facing humanity, probably. We should be tackling this with the sort of money that we put into world wars. You know, if we put that sort of investment into negative emission technologies and into mitigation, this is the level of investment we need, way, way more than we've currently got. If we throw some money at it, I think we will be able to get there.
Yes, Lynn?
Yeah, thanks for the question. On the scale issue, indeed about 30 megatons a year is currently stored. It's mainly in enhanced oil recovery operations. So that means that you inject CO2 in an almost depleted oil field, and you basically use it to mobilize more of the oil out of the reservoir. So it's basically leading into the use, or at least the recovery of more fossil fuels, and therefore in CO2 emissions. So it's quite a bit controversial there. But 30 megatons of CO2, it's actually, it's not that much. But the nice thing about this technology is rather modular, right? You just need more of the same, essentially, in making it happen. So you just need more of those plans. And why are they not happening? Because economic incentives are just completely absent in most parts of the world, apart from with this EOR, because that obviously gives you more money if you can sell that oil. So can we scale? I think that is really dependent on what kind of incentives the governments are putting in place. It's not going to come from business alone, at least not at the scale we need. And can we do it fast enough? Well, I mean, China for a few years has been building a coal-fired power plant a week. Right? They managed to do that. If you can do that, you can also build CO2 capture plants at that scale. So I think that's not the issue. The knowledge is there. The technology is even there. We need more experience with that. Cost needs to come down. And actually a good public perception program is also very much needed. But I think all the ingredients are there. It's really a matter of having the right policies in place in order to make it happen, and having the right support for those kind of policies to make it happen, have the political will behind that. But I think there's examples of where we've seen operations like that at scale in the past, so I think that is possible.
Thank you.
So perhaps a slightly different perspective on the moral hazard and maybe the ethics of carbon capture and storage and bioenergy with carbon capture and storage. So what bioenergy with carbon capture and storage does, it allows us potentially to overshoot our carbon budget so that we can carry on emitting for longer, and that's emissions at a global scale. It also potentially allows us to continue burning fossil fuels in sectors which are harder to decarbonise. And we've heard already that electricity is quite easy to decarbonise, which then brings us on to perhaps the two tricky sectors, shall we say, which would be international aviation and international shipping. And I suppose this is where I'm going to channel my inner Kevin Anderson, and I'm going to say that we're all sitting at a conference in Vienna. Possibly a lot of people here might have come by train, by car, by public transport. A lot of people here might have flown here. So in essence, as researchers, as people who live in higher income countries, we are the problem when it comes to climate change mitigation. the luxuries that we enjoy compared to the majority of people globally are one of the reasons that we need carbon capture and storage and bioenergy with carbon capture and storage. So from an ethical perspective, these technologies potentially are attractive to us because they allow us to continue our behaviours, they allow us to continue with the lifestyles that we enjoy whilst hoping to avoid inflicting climate change impacts on those who don't get to enjoy those lifestyles, which I think is possibly one of the kind of nuggets as to why BECCS and carbon capture and storage is so attractive.
Thank you. Any questions, comments?
Yes, my name is Ed Gregorich. I work for Agriculture Canada, the Federal Department of Agriculture. So my area or understanding is fairly narrow, but I guess my question to the panel is, what are some carrots and sticks or encouragements or things to discourage behavior to adapt these CCS technologies? I guess I'll give you an example in agriculture. That when I speak to farmers, we talk about nitrous oxide emissions, and the nitrous oxide produced is actually a very small amount of the nitrogen that they apply. But when we talk to them and say this is a leak in the system, this will, if you close this or reduce this leak, your systems will be more efficient. And they get it as soon as you start talking in that sense. It's a small amount, but they realize efficiency is what they're all about. They want to be efficient, and that is sort of encouragement to them to adapt something that we tell them about, a new technology. So what I'm wondering is this a broader thing to explore across different sectors, or even in a particular sector?
Thank you. Shall we take one more question and then come back to the panel?
I've got quite a broad question. Doesn't investing in CCS generally seem like treating a symptom rather than the cause of a problem?
Thank you. So who would like to respond to the...
Yeah, thanks for the behavior or maybe public perception question. So I'll give you an anecdote from the Netherlands. In 2007, the company Shell and the Dutch government agreed on implementing a sort of ideal CCS project. It was CO2 from a refinery, from the hydrogen production of a refinery, which means it's a fairly pure CO2 source, very cheap to capture. You basically only needed to compress it. The pipeline was already there, and there was a depleted gas field, which is about to be shut down, and which basically could be used for the CO2 storage. So Shell filed for a subsidy. Subsidy was given, and the operations could begin. And then they decided to also inform the people who lived above that gas field. There was a big neighborhood there, and it's called in a town called Barendrecht. And the people there didn't like it at all. Right? They felt basically not included in the decision making. They were seeing all kinds of risks to the CO2 storage, even though they've been living on top of a methane field for a while, which is in many ways a much more dangerous gas than CO2. But they revolted, and they revolted very strongly, and to such a degree that actually the project was abandoned, had to be abandoned. It was a very interesting dynamic of people resisting a new technology, actually people not being engaged in the decision making around something happening. And the example that you give from agriculture in Canada is a good example of how you do take along people in that decision making. And I think for CCS that's also an absolute condition. We have to get much smarter about how to handle these things, and it's going to require a lot of investment, and that's generally what the engineers forget, right? They in the economic assessment of a CCS project, they file the capture plans, which is a big part of the investment, the pipelines, the storage infrastructure, and then maybe at the end they think, okay, maybe we should do something about the people inhabiting the area and how to take them along. And that's really poor practice, I think, and that really needs to change. So we need to be much more multidisciplinary about that. So let's take the lessons from Barendrecht, I would say.
Thank you. Pete?
So on the question about treating the symptoms rather than the cause, I agree. It's like we've had a patient that's been smoking too much, and we told the patient stop smoking 20 years ago, but the patient kept smoking and smoking a lot. So we're now in a position where we have to not only tell the patient to stop smoking, but also treat the lung disease that's arisen from that. So I think we're just in a position now when, of course, we have to tackle the root problems. That's why I say that immediate and aggressive mitigation has to happen. That's what's causing the problem. But at the same time, because we've gone too far along the track of our, the cumulative emissions that we can afford to emit before we hit 2 degrees Celsius, then we need to tackle that as well. So I think we need both. We need both the remedial action to address the problem, as well as to try and address the core symptoms. On Ed's point, I think it's great where we have farmers and we're trying to incentivize them to reduce their emissions. We can sell it easily because we've got a whole bunch of people that we're saving money. So I think that's a good example. I guess what is a bit different about the carbon dioxide thing is that we are all actually the end users of that, and we're emitting carbon dioxide. So for us, I mean, I suppose the easiest equivalent is looking at, sort of like improving energy efficiency so that you save money. So that's the best one. But I guess in terms of CCS, if we're just looking at CCS, there are necessarily this is not something that an individual person does. This is a decision we take as a society. So, it's in the hands of the people who are building the CCS plants. So I think it's probably a little more difficult to incentivize in that sort of way of saying it's going to make a saving. It's more a decision that we have to take collectively as a society, and we have to recognize the scale of the problem. This is not a cheap problem. We're going to have to invest maybe trillions of dollars in this. That's not going to be an easy case to make. But looking ahead at the counterfactual of what happens if we don't, how much more money do we spend on insurance and clear up and disease and mass migration if we don't address the climate change issue? I think that's the counterfactual future that we need to look at in order to incentivize society to decide that this is worth spending our money on.
Thank you, Pete. Sarah?
And I suppose just kind of carrying on that point, we often talk about the benefits of CCS. They're framed in kind of a global, it's for society's greater good that we can reduce emissions. But perhaps when we're thinking about carbon capture and storage and particular schemes, those benefits should be reframed to the national, to the regional and to the local. So in terms of, we've heard about the power of the oil and gas industry, but many oil and gas players could actually be winners if we do carbon capture and storage. The company, if we're going to be using depleted oil and gas fields, then that expertise comes from the oil and gas industry. The engineering expertise may well come from process engineering from the oil and gas industry. So that particular industry, yes, there will be losers, but there can also be winners. And then sort of taking that down to the national and to the local context, there will be local benefits from employment, for example. So I think reframing from these kind of global and starting to think about what the positives for CCS can be for particular industries and particular communities would be a helpful way to think about it.
Thank you, Sarah. Yes, please.
I was wondering if there's a point to bring the discussion back to square one, following on a point that Pete made. You mentioned that the IPCC scenarios mostly require a carbon capture and storage. But if we really wanted to do it without, then we don't need a majority of scenarios, we need one that works. So just, is there one that would work without?
Thank you. Yes, please.
My name is David Caroli and I'm an Australian, as you can tell from the accent, but I'm also a climate scientist and sit on the supposed advisory authority that provides climate policy advice to the Australian government. That advice is usually ignored. Yeah. I should add that the Australian government has instituted a new climate policy review, and if anyone here wants to make a submission, you can until Friday of next week. It is not limited to Australians. Anyone can make a submission. Australia potentially is the biggest winner as a country from effective and efficient carbon capture and storage, so it is in the nation's interest. The Global Carbon Capture and Storage Institute is based in the city in which I live. It was established 9 years ago. It hasn't made a lot of progress, but it has a lot of members. So my question is, after that introduction, thank you very much for doing what you've done and preventing all these issues. There's a lot of agreement up there. How do we incentivize global carbon capture and storage and regional carbon capture and storage? Is it through government regulation? Is it through government handouts to industry? Or how do you persuade industry that it's in their benefit to do it? Who pays and how do you incentivize it?
Thank you. Anyone? Yes, please. Thomas?
Yeah, so I can talk a little bit about the scenarios and maybe also a little bit about how they're done. But first, if we go through the big database that was published with the R5, in which there are something like 1,000 scenarios. So this database was used to write the IPCC report, and we can easily see that almost all the scenarios that limit warming below 2 degrees include CCS, but they made some attempts to, well, they made scenarios without CCS, and some of them, a few of them, something like, I don't remember, 6 out of several hundreds, managed to limit warming below 2 degrees without CCS, but in every case they rely on a very intense reforestation. So this is another challenge with CCS and bioenergy and food security that we haven't mentioned yet. But I think it's important to understand how these scenarios are made. They basically, those are quite simple economic models that, in a sense, find out an emission pathway to optimize the given cost. So when they implement CCS in those models, they make some assumption about cost of the technology, scalability, and the benefits are the reduction in CO2 emissions. But so we have no idea what's the real cost at the global scale of CCS, of the technology. So basically with those models you can create the scenario you want. And so for the IPCC R5, the modeling team were asked to produce a scenario that actually peaks below 2 degrees, and they managed. And now for the next report, the 1.5, the modeling team were asked to create scenarios that stay below 1.5, and they manage. So I think this is actually a perfect example. It's the manifestation of this moral hazard we were mentioning.
Thank you. Yeah, sure.
Yeah, so maybe on the models, but also on the policy questions. I mean, these models have, as Tom has been saying, they have huge problems, and they are, systematic representations of the world. But we all know that whatever happens, it's not what's in those models, right? They are not real, and they assume that people and countries and all kinds of actors in the system make decisions on the basis of optimization, economic optimization, which we all know, every social scientist knows that that's not the way people make decisions. And what these models also, they generally assume continued economic growth all over the world, including in developed countries. They assume cost optimization. They assume that nobody wants to scrap capital. So before a power plant actually is over its economic lifetime, it will not be scrapped. If you would allow that to happen, as we've seen in the past, for instance, in nuclear energy, then you would actually be saving a lot of emissions or a lot of committed emissions in the future, and you would be able to get to much lower emission scenarios. It's, again, a matter of political will. If that political will is there, then suddenly a lot can happen. So I generally, I think the models are nice illustrations of what the future could look like. It's really a useful exercise in that, but we really should not treat them as the truth. I mean, really, I think that's very important to realize. So, and it's also not been a very convincing way for policymakers to invest in CCS, apparently, because we've already seen the outcomes of these models for decades, and policymakers basically haven't acted on those outcomes at all. So I don't know how convincing they are. So yes, it's definitely possible without CCS, and don't pay too much attention to the models. On the policy, how to make a CCS happen in Australia or elsewhere, it really depends on the consequences, on the circumstances. We've seen, for instance, the first CCS project in the world was the Sleipner project in Norway. That was the consequence of a carbon tax on offshore oil and gas operations implemented by the Norwegian government. It was a tax of about $35 Norwegian krone equivalent per ton of CO2. And it just made, for Statoil, made a gas recovery operation more cost effective if they would store the CO2. And that's been operational since 1996, so quite a long time. So a tax would probably work, and it's a very predictable instrument. It's very clear what the industry should do. The CO2 price could have the same effect, but it seems to be a bit more volatile in Australia as well, where people go from tax to price to non-price at all, etc. And also in Europe, we've seen that an economic crisis, and you have a very low price, and your incentive is gone. I think the Clean Power Plan of the Obama administration was actually an interesting idea, because it essentially regulates the electricity industry. It made it impossible to build a new coal-fired power plant without CCS. You could still build gas, but essentially, if you wanted to build coal, you would have to do it with CCS. It's sort of a mix between regulation and something else. I think that the sort of the easy capture options, so the pure CO2 sources, just regulate it. You know, don't fiddle around with CO2 prices and complicated instruments. It's so cheap. It's so attractive, it's just irresponsible not to capture and store that CO2 if there's a storage location in a neighborhood. So I think every country will make its own choices. Some countries like taxes, others don't. Some countries are willing to regulate, others are not. But one thing, don't rely on industry to do it, because it's just too expensive. They will not do it.
Thank you. Did you want? Okay. Yes, please. Can we have another question?
Hi. I'd just like to pick up on a couple of points. First, about the public perception and bringing the public along for CCS projects, and kind of related to that, the relationship between government and the oil and gas industry. So I speak as a complete layperson here, but I understand that in the UK, fracking for shale gas is going ahead in certain areas of northern England, despite kind of widespread local opposition. And I guess I'm not an expert, but my feeling is that the reason that's gone ahead is because the government has made it a kind of priority, a national priority, to go ahead with and develop a shale gas industry. So there seems to be quite an interesting parallel with thinking about political will here, the way that shale gas, with all the attendant possibility of new emissions and the kind of the public worry about it, can go ahead, and yet CCS projects, which seem certainly quite superficially, they seem very, very attractive in comparison, they are not going ahead. So I think political will is really, really important.
Thank you for your comment. Yes, please.
I guess, hello, my name is Janet Chen, and I'm a climate change impact analyst, but more importantly, I guess, relevant to what I'm going to say, I'm a US citizen. And kind of as a follow-up to what the previous comment said, and you guys have talked about being in agreement that we need CCS, we need to work in a synergistic relationship with the government, with policymakers, not so much with industry. But as a US citizen particularly, I'd like to point out that in our country, science is under attack. There is a decrease in EPA regulations. There is a decrease in funding. There is also silencing, such as with the USDA. And so in that sense, knowing where we have to go, how do we fight better to communicate what's important, not only for us, but for society and the planet?
Thank you. Anyone? Pete?
Well, yeah, just on the last point, yeah, my heart goes out to you with all the issues that you're having to deal with in the US. I guess this is where, you know, where we sort of say maybe this is making an excuse for the oil and gas industry to continue. Maybe we can, and that's why as environmentalists we don't like the idea, or at least we think there's a moral jeopardy there. Maybe this is where where CCS would actually be, this is one of the more compatible environmental solutions with continued oil and gas use. So whilst I think it's abhorrent that any country should be moving in an opposite direction in terms of emissions reduction, maybe there's a case to be made there by saying, you know, if we can crack this technology, then we could export this technology abroad. Maybe we have to make the business case to the people who don't believe in climate change to sort of say, okay, if you don't believe in any of this stuff, at least try CCS, try and get good at this, and then you can, you know, so we turn the argument on its head, say this is one thing that is compatible with your crazy energy policy.
Thank you.
So just thinking about, I suppose, social responses and the kind of the question about the UK and shale gas and carbon capture and storage, I would agree wholeheartedly that that the Conservative government sees shale gas as being important, which is why it is, you know, it feels itself able to overturn the decisions of local planning authorities and kind of go against the sort of the kind of your local scales of government, because from an infrastructure perspective, shale gas, you know, is planned for in such a way that it's seen as in the national interest. So kind of central government has the final say, and that certainly in the UK, central government has never been as supportive of CCS. And so I mean, you know, we've had funding competitions, but I think in the UK it's the Treasury. You know, whilst you have lots of government departments, they are not all created equal. And so what carbon capture and storage hasn't had is the kind of the support and the ear of those who really have their hands on the purse strings, which, you know, is the Treasury realistically. And also, I think for CCS, it's been, since 2005, it's always been the technology that's talked about. You know, it's reported on in the media a little bit, but it's a lot harder to kind of keep public interest, keep people's attention in a technology that's a series of policy announcements. It's a series of kind of announcements about something that doesn't exist. And the advantage that renewables and shale gas has is that it's real. It's kind of, it gives people something to talk about, and it's a technology that has a face. Yeah.
Thank you. Any more questions, comments?
Yes, I'd like to offer a couple of comments, observations. Like David Caroli, I am an Australian. David Caroli and I are good friends because we disagree on just about everything. But I'm going to make a couple of observations which many will no doubt disagree with. But picking up a couple of key points from what our speakers have said, we're going to have to, for CCS to be really effective on the global scale, we're going to need an investment of about 10 times the amount of pipe works as we currently have for natural gas. That's colossal. We also know that when we employ CCS, we lose about 40% of the energy that's lost in the CCS process. So that's quite a large disincentive. We also had the observation that we're going to need a world government, quote unquote, in order to get the level of coordination needed for this level of global CCS. Well, I'm a pessimist, ladies and gentlemen, because I don't think any of these things can happen. The world is moving towards nationalism. It's moving towards less control by international bodies. So the control that's necessary for those steps, as well as the investments, are not likely to happen. I can see two possibilities for us to achieve our 2-degree limit. One is the progressive implementation of fusion power. It was mentioned, it doesn't exist yet, but 50 years ago when I was an undergraduate student, it was 50 years away. I'm not sure that it's 50 years away now, but it might be getting closer. And maybe fission power, a big investment in fission power can bridge the gap. That's one way we can get towards 2 degrees. The other is that we could achieve 2 degrees if the transient climate sensitivity is in fact at the low end of our current range, which is a big range, 1.5 through to 4.5. If the transient climate sensitivity is at the lower range, we'll get there anyway, and we then can put our efforts into issues of local environmental safeguards and issues of starvation and poverty overseas. One of our speakers mentioned a counterfactual of we have to consider what would happen to the world if we don't do this CCS project. World of disease, starvation, etc. But there's another counterfactual that I think we also must consider, and that is if TCS is in fact at the low end, then over the next decade or two, our science will take the most dreadful public beating of any time in history. We need to do more to tie down TCS to cover this possibility that we might be wrong. And there are a couple of very, very important papers in Nature which have been published in the last 6 months which have addressed, addressed this issue of TCS. And there's one beautiful quotation from John Fife's paper on analysing the slowdown. This raises the interesting science questions. Are we living in a world less sensitive to greenhouse gas forcing? That's just one quote. There are certainly many scientists, a minority, sure. There are many scientists who do move towards, in their thinking, towards a low TCS, and I think we have to evaluate it much more carefully than we have, because if we don't, we could be giving awfully bad and dreadfully costly advice to our governments.
Thank you. Can I please have the speaker at the back microphone first? Thank you.
Yeah, I guess my question is, fossil fuel companies are incredibly powerful, more powerful than many countries, and very rich. They are the biggest losers when we talk about cutting emissions, and therefore the biggest winners of this technology, because they will still be able to use all the fossil fuels that they own, and they are still buried. So I keep hearing about governments have to invest in this technology, but why? Shouldn't governments be investing in the other technologies like renewables and just making the fossil fuel industry, which are the biggest winners, invest in this technology? Or is the technology not feasible? Why are they not investing?
Thank you. Shall we take one more?
So soil sequestration of carbon came up as a brief mention at the beginning, but that seems to be quite a viable alternative in terms of a large-scale decrease of yearly emissions into the soil. But how viable is that through changing farming practices to sustainable from industrial? And also with the UK leaving the EU and with the reduction of, well, stopping the cap funding, can we really affect policy in the UK to switch to sustainable farming from industrial as well? I guess.
Thank you. Pete?
Well, I suppose I'd better take the soil one. Yes, so we think there's about between 0.4 and 0.7 gigatons of carbon per year possible from carbon sequestration, and maybe about another 0.7 gigatons from bioenergy when you take account of all the other waste streams. So there's a potential there. It's not as large as you would get from large-scale afforestation, reforestation, or from bioenergy with large-scale bioenergy with carbon capture and storage. But there's not a magic bullet. And the good thing about soil carbon sequestration, okay, so it's not permanent, it's reversible, so there are some issues associated with it. But in terms of looking at the land footprint, it's something that you can do on land that you can still use for food production. So the competition for land issue is not there. It's water efficient, it doesn't cost any energy. So in terms of the negative externalities, as long as we take account of, not increasing nitrous oxide emissions by increasing the soil organic matter in the soil, we can take care of those issues. I think it's a no-brainer, so something that we should definitely do. Some of the other natural solutions I mentioned at the outset were, sort of restoration of drained organic soils, huge emission reduction potential there, where these soils are just, churning out carbon, maybe, 50 tons CO2 per year. Switching off that source is another thing that we can do in the soils. So I think we need to leverage a whole bunch of those natural solutions and then look at what we need to do on the top of that. But I think we probably do need a mix. That's why I'm urging. So I don't agree with the characterization that we will be in trouble if we back the wrong horse. I think we need to back every single horse in the race and see which one starts to win and then invest more in those technologies. We don't know enough yet about how these things are going to scale. So we should be, in my opinion, investing in all of these. Enhanced weathering of minerals to remove CO2. Direct air capture looks very expensive, very energy intensive, but we learn by doing. So let's try doing some of these things, try scaling up, and see which ones lead us in the right direction.
Thank you.
Yeah, in reply to David Crowley, I think it was, you must be the first pessimist who's optimistic about fusion. and actually lower climate sensitivities as well. Because I think that's really, really long off. Yes, you have to bet on all horses, but some of them have by now kind of demonstrated that they will probably not run fast, even when things succeed. And what I've seen of fusion, and the little I know of it, it seems to be in that ballpark. I think I would actually have more faith in CCS than in fusion at this point. And you said that we need a world government for that. Well, that would certainly be helpful, but I don't think that was said here. World coordination is something else than a world government. I think every country will have to follow its own path. Countries have different interests, different structures of their economies, different preferences, different public mandates, and you will have to work with those, and that's very, very important. So it will be a patchwork of different policies, of different regulations that we'll see globally, but hopefully all leading to the same outcome, which is lower CO2 emissions and concentrations. On the point on the fossil fuel companies, yes, it makes a lot of sense, especially when the oil prices were high. Shell and Exxon had profits of $30 billion a year. $30 billion, that's really a lot of money. If they would invest that in carbon capture and storage operations, that would be very helpful. But that's unfortunately not how these companies work. They have shareholders. These shareholders want basically the payments from their shares. So a company basically makes a decision, where do I invest my money? And they always invest it in the place where the profits will be highest. And especially the oil and gas industry is used to investing in high cost but very high revenue type of projects like exploration in the Arctic, for instance. And they take the risk that this is not going to pay off. And that's what we've seen in the past few years. Now, we have now with the lower oil prices, actually the interesting circumstance that when the oil prices were high, you would say, well, you know, renewable energy gets more attractive, energy efficiency gets more attractive, so you see more investments in that. That's actually not what we've seen with high oil prices. In high oil prices, oil and gas companies invest more in oil and gas because that's what they get more profits out of. So now we're seeing declining oil prices, which is actually good for CCS because it is so energy intensive, and lower energy prices is, basically means cheaper CCS. So what you see now is that oil companies are looking more into other options. Shell just invested in an offshore wind energy plant or park in the Netherlands. So it's this interesting dynamic between, and it's all driven by oil and gas, by fossil fuel prices. That's what companies are doing. But you're absolutely right that it feels very awkward that governments are helping very rich fossil fuel companies to invest in CCS. And that's why I think the Clean Power Plan of Obama was so interesting, because it basically was not costing the government any money, because it was basically regulation. And there are industries like the steel industry, which is very internationally trade sensitive and which operates on very low margins at the moment, where subsidies might be justified. But again, you have to look at the sector, you have to look at the national circumstances in order to determine what kind of policies would work and would be responsible.
Thank you. So thank you all for your comments and questions. I think in the interest of time, I will now come back to the panel for their concluding statements. So maybe this time in reverse order, if you can give your final thoughts on the debate.
So, concluding remarks. I think I've made myself pretty clear. I don't... well, first, I really believe there is no way we can reach 2 degrees without carbon capture and storage. But I actually don't believe that we can have carbon capture and storage at the level that is required, and especially implemented at the speed that is required. So basically what I'm saying is that I don't believe in the technological solution, so we're left with the behavioral solution. And I don't really think either that the humankind can really change that fast. So basically, I don't believe in the 2-degree target. But I'm French, I'm allowed to be pessimistic. So is this really a problem? Well, first, if we actually reach 2.2 or 2.5, well, maybe it's still a good thing in a sense, and we can probably all agree that if we get there, we'd be lucky. Second, so the 2-degree target and even 1.5 are mentioned in the Paris Agreement. So is this a problem? I mean, Paris Agreement is really the result of a political process, and so these 2 targets are, to me at least, are really just political targets. And there are some good political reasons to use those targets, even if unrealistic. Now, my third and last point is more, there is something that I am more puzzled with, is how the scientific community and especially the IPCC jumped into the fray, if I can say so, and how the community is investing time and money and energy in what seems to be, again, to me, somewhat pointless topic. So I'm not saying that we shouldn't study this at all, those very low temperature targets, because this is also part of what science is. I mean, to investigate what is impossible, or at least what seems to be very unlikely. But what I'm saying is that I don't like how these political targets are actually shaping the way science is done. So I may be an idealist, but yeah, food for thought.
Thank you.
Thank you. So, am I an optimist? Maybe I'm an optimist. So what would be my causes for optimization? So, I mean, I think that increasingly over the coming years, climate impacts will will become increasingly prevalent and could increasingly become a driver for action on the mitigation front. Whilst we don't have carbon capture and storage, we still have some. So we do still have boundary dam. In Scandinavia in particular, there's work looking at bio-CCS, and so storing those easy to capture emissions from biogenic sources. So for whatever reason, companies and governments, there is still activity and demonstration going on such that when the time comes, if carbon capture and storage is called upon and there's the political will to push it forward, then there is evidence and research base there. I also think that as climate scientists, as social scientists, as natural scientists, as engineers, as whatever, we have a responsibility not to be quiet, to carry on talking about the solutions that we know about, to adapt our discourse to reflect perhaps the growing localization and national, national interest rather than global interest. So how can we frame our solutions to talk about co-benefits, to talk away from the global and talk about the national, talk about the local. And also to be clear, to be honest and upfront about what our particular values are. So at a time when scientific expertise, people across all fields, expertise is being doubted, let's be honest and say, these are our values, we're transparent, we're open, such that when, if political will changes, then we're ready with the menu of options ready to go.
Thank you.
Yeah, I've been working in climate policy for 15 years now, so I gotta be an optimist. Otherwise, I wouldn't do my job well. I think the Paris Agreement put an aspirational target of well below 2 degrees and pursuing efforts for 1.5 degrees, and I think that's exactly where the value is. It's an aspirational target that hopefully inspires people to look at our energy system differently, at our consumption systems differently, because I think the biggest driver of CO2 emissions is actually consumption. It's economic growth. It is that what's really driving global emissions. So at the core, that is what needs to change in a way that social systems are also beneficial to people. So I think that needs to inspire everybody's thinking on this. And that's basically not consistent with continued use of fossil fuels in the long run. So we do need to wean off fossil fuels, as Pete has been saying. And whether CCS is actually delaying that or not, I think we don't have the luxury to think about that question very much, I'm afraid. We just need to keep our eyes on the ball, go for that really deep target, see how far we can get, and invest basically in all the options there are. But I think the 1.5 versus the 2 degrees, to me, it really begs different questions about the economic system that we're living in. And it really puts much more emphasis on behavioral change, on radical innovations, on different economic systems. And I think that possibly could be the value of looking at an aspirational target like that. So I'm even a greater idealist than you are, Thomas. But I really think that's what the discussion we should be having, also in the special report on 1.5C.
Thank you.
Yeah, so I wish we lived in a world where we didn't need CCS and where we didn't need greenhouse gas removal. And if we had taken the climate issue more seriously 20 years ago, then we may still be in a position where we could do this all with mitigation and abatement. But I think we're no longer in that world. We probably are going to need greenhouse gas removal on top of aggressive and immediate mitigation. I keep emphasizing that because it's not an either or. And I think there's going to be a number of pathways to get there. What's clear is that we don't have a magic bullet. No single technology is going to get us there. And with any pathway in the future, I think there are going to be winners and losers. So there are going to be winners and losers associated with any technology that we eventually settle on. And it's going to cost us, if we tax the fossil fuel industry, we are the consumers of their products. So we end up, that's going to be passed down to us. So we're going to have to, in some way or another, pay more money for the consumption that we have. But when we think about the winners and losers, you know, through the technology, so we also have to think about the winners and losers of the consequences of inaction. And whereas it may be okay for me from Northern Europe to say, well, if we don't hit 2, maybe 2.5 is not so bad. For me in Northern Europe, that's probably okay. For the people who live on the low-lying island states, you know, that's a death sentence. So we also have to consider the winners and losers in the counterfactual world of not addressing this as strongly as we possibly can. We really need to raise the profile of the potential consequences of inaction so that we can invest the many trillions of dollars that we need to address it. Not on research. This is not necessarily just giving the people in this room more money. This is about real demonstration and changing things, building the infrastructure that we're going to need for 2050 and beyond.
Thank you, Pete. Well, thank you all for joining us this morning, and thank you for all your comments and questions. And please join me now in thanking our excellent speakers this morning. And if you have any more questions or comments, please feel free to come to the front.
Thank you.